So listen to it carefully, because this will come in very handy in grid problems, dynamic programming problems, and many other problems. This term is used quite a lot actually, that is the reason. So let us see what is this Manhattan distance. So currently we saw a kind of distance, right? So let's say there is a point P1 and there is a point P2 and they have a distance in between them which is D, right? If you know the coordinates of both the points, can you compute the distance? Yeah. So if 2 points are given, you can determine the distance in between them, right? Now tell me one thing. What is this distance called as? This has a name. This is called as Euclidean distance, isn't it? Which is, yes, no, yeah. Which is the straight line connecting the 2 points. What is the length of straight line connecting the 2 points? Now, what is Manhattan distance? So Manhattan distance means that if, let's say, there is a point which is like 2 comma 2 and there is another point which is like 10 comma 11, then it assumes that, hey, you cannot walk on any straight line. Rather, you can walk only in this way. Either you can move along the x-axis, or you can move along the y-axis. These are the only two kinds of moves that you can have. Okay, so if these are the only kinds of moves that you can have, can you tell me after how many moves you can reach from here to here? After how many moves would you be able to reach from 2 comma 2 to 10 comma 11, considering that you can move only along the axis, either along x-axis or y-axis? 17. Okay, yeah. And how did you figure that out? Because the number of moves will be number of moves in x-axis plus number of moves in y-axis. Number of moves in x-axis will be x2 minus x1, and number of moves in y-axis will be y2 minus y1. So this thing is called as Manhattan distance. And sometimes what can happen, that you can have the other point anywhere, right? So you do not know which one of them will be greater, but you are interested just in the magnitude of this distance. So you can put a mod over here. So if there are 2 points x1 y1 and x2 y2, the Manhattan distance between them is mod of x2 minus x1 plus mod of y2 minus y1. So you can very simply assume it as if there is a grid, okay, and let's say this point is 0 0, this is 0 1, 0 2, 0 3, 0 4, 1 0, 1 1, 1 2, 1 3, so on. You will have 1 0, 2 0, 3 0, 3 0, 3 1, 3 2, 3 3, okay. So if you have to reach, let's say, from here to here, and you can only move, and you are just talking about the shortest distance, so you will not move down or something like that. So in that case, this is the path that you might take. You could have taken other paths also, but again, Manhattan distance within that would have been same, which is 3 plus 3, that is 6. So this is the actual meaning of Manhattan distance. Don't treat it as a formula, treat it as a logic. So I told you that what is the doubt over here? Like, the coordinate of this x coordinate is x1, the x coordinate of this is x2. If you have to reach from one point to other point, the number of times you have to move in x, that will be the distance between x1 and x2, and distance between the x1 and x2 is this. And you have to move in y-axis also, so that will be distance in y coordinates, difference of y coordinates, that is mod of y2 minus y1, right? Got it? That is the case over here also, right? That is what happens in grid. I think we had done some questions in maths chapter where something like this was there. Okay, now listen to the original question. The question says that there are many points, P1, P2, P3, P4, okay. Now you can easily use this formula and compute Manhattan distance between any pair of points. But what I want you to do is, I want you to do something like this. Find sum of Manhattan distance between all pairs of points. sum of Manhattan distances between all pairs of points. How many pair of points will be there? If there are n points, how many pairs of points will be there? I do not want repetition. NC2, right? Very good. So if there are n points, there will be n into n there will be NC2 pair of points that will be out there. So you have to consider all those pairs. For every pair you have to compute their distances and you have to sum those distances up, and that sum is supposed to be my answer. Okay, and of course I do not want any repetition to happen. By repetition I mean that if you have computed distance between P2, P3, then please do not compute the distance between P3, P2 again, because this is a repeated pair. Okay, so how you can think of it is, let's say you start with P1. Okay, so first you compute the distance between P1, P2. Okay, let's say this was D1, and then you compute the distance between P1, P3. Let's say this is D2, and then you compute the distance between P1, P4. Let's say this is D3. Okay, now you have computed the distance of P1 from all other points. Okay, now let's say you pick another reference point which is P2. Will you find the distance between P2, P1 again? No, because P1, P2 was done. So for P2, the points that are left are P3 and P4. So you will find distance between P2, P3 and P2, P4. Let's say this distance is D4, and between P2, P4. So let's say distance between P2, P4 is this, which is D5. This is D5. Okay. So now with P2, all the other points have been considered. P2, P3, P2, P4 and P2, P1. Now you can pick the next reference point as P3. So for P3, P2 and P1 are already considered, only P4 is left. So now distance between P3, P4, let's say that is D6. Okay. Everything with P3 is done. P3 is considered with P4, with P1 and P2. And now let's talk about P4. Is anything left with comparison for P4? No, no point is left. So that is useless. So I want you to return me this, the sum of this. So think how you can solve this. And maybe before you try to optimize or do anything smarter, first just try to come up with the most brute force solution to it. What do you feel will be the brute force approach of solving this? Yeah, n square, isn't it? You can simply consider all the points, you can simply consider all the pairs and compute their distances. Yeah, so you can do that. And the time complexity of that would be order n square. Why order n square? Because computing Manhattan distance of any particular pair is just a constant operation. This operation is just order 1 operation. So different points are given to me in form of a vector of pairs. Okay, so you can consider all the non-repeated pairs in this vector. So you can start from I, go on till vector dot size -1. Now within this, your j should start from I plus 1 because you do not want repetitions, right? V dot size -1. And now this denotes Pi and this denotes Pj. And now you are interested in the distance in between Pi and Pj, and that you can compute using this. And you can add that thing to your sum. Okay? And this is how you can solve it in order n square. Correct? Is there a way which is better than order n square? If we sort them, that is a right observation if you sort them, but how will sorting make your life easy? You're saying P3 minus P1. Okay, you want to sort based on which thing? Because a pair comprises of X as well as Y. So do you want to sort based on X? Do you want to sort based on Y? Do you want to sort based on the distance? What do you want to sort based on? Okay, first X, then Y. Okay. and now just try to tell me how will that help. Are you understanding? There can be cases like this. If let's say you are sorting based on first you are sorting based on x. So what will happen is that let's say there is a point over here p1, okay. Now let's say there is another point p2, says that p2's x coordinate is greater than p1's x coordinate. So p2 can lie anywhere in this zone, okay. It can be on the same line also, it can be below this line also, and it can be above this line also, okay. Depending upon all these cases, the sign with which modulus will open, if x is same, then take y. Okay, but let's talk even more basic case than that. If let's say x coordinates are not same, okay, if because you are first sorting based on x, so this point will come first and the other point p2 which has a larger x coordinate will come in this zone. Now depending on its y coordinate, it can either lie above it, it can either lie below it, or it can lie on the same line also. And now these different configurations will impact the way in which this modulus is going to open. For some points lying to the right side of P1, modulus will open with plus sign, but for other kind of points which are lower than it but towards the right of it, the modulus will open with negative sign. So you might want to take those cases also into your consideration, whatever you are thinking. Yeah, so what Ankur is saying, that makes much more sense. He's saying we do independently, first based on x and then based on y. Okay, so guys, I'll give you a hint over here, and that is very important thing, and that will help you a lot while dealing with the questions where equations contain modulus in them. So how to open modulus? So first try to understand one thing. If there is an expression that says mod of a minus b, in how many different ways does it open? Two different ways. If a minus b is non-negative, then the result of this will be nothing but a minus b. But if a minus b is negative, then the result of this will be b minus a. If negative. Isn't it, guys? Yes, no? That is how your modulus opens up, right? And you are not simply able to figure that out. And that is the reason you are very confused that how to open up these modulus signs, right? That is the reason you are confused. Cool. Now let us try to understand one thing, okay? I will give you an example and then just try to understand that. Let's say the points were something like this. Points were minus 1, 5, 1, 6, 3, 5, 2, 3. How will this look like? Minus 1, 5. This is here. 1, 6. This is 1, 6. 3, 5. 2, 3. 2, 3. This is 2, 3. Okay. So think of it in this way. Can I consider x distances separately and can I consider y distances separately? Do the distances of x coordinates, do they tamper with the distances of y coordinate? Can't we use absolute function? How is that going to help? Again, how is that going to reduce your time complexity? You tell me that. How is that going to? That was what you were doing over here. So whatever you were doing here, you were doing, I presume, you were doing by taking absolute difference only, by using that little function that you have written, isn't it? Yes, no. So how is that going to? The main point over here is this. The main point over here is this, that if I consider a point, let's say this is my reference point P1, can I compute the, distance of this point from all the other points, the Manhattan distance of this point from all the other points in a much more optimal way? Is there a way I can do that? And that is what we are going to learn. Okay. So see, what I was saying was something like this. When you are considering different points, okay, I'll just take 3 points for my example. So let's say x1, y1, x2, y2 and x3, y3. So first you will have distance between these pairs, which is mod of x1 x3 plus y1 y3, and then distance between this, which is mod of x2 x3 and mod of y2 y3, and then this, which is mod of x1 x2 and mod of y1 y2. What I was trying to say was that this is x coordinate distances and this is y coordinate distances. Okay, now my point is, can I consider those distances separately from each other? What I mean by that is, see, here it could have opened like x3 minus x1, it could have simply opened like x2 minus x3, and it could have simply opened like x1 minus x2. But the point is, irrespective of however these modulus are opening, are they having any impact on the result of this? Are they having any impact with them? No. They are having no impact with them. So my point is simple. My point is, first you calculate the sum of x coordinate distances and call it sum 1. Similarly, you calculate sum 2, which is sum of y coordinate distances. If you are able to do these two things efficiently, then your overall answer will be S1 plus S2, isn't it? Right? Now you think how you can do that efficiently. If you are first dealing with all the x distances and then you are dealing with all the y distances. Is there a way to do it efficiently? Think. Now it's just like these were the 4 points that I had drawn. So for all these points you want, so these are the 4 points that you have, and you wish to compute mod of xi minus xj for all the pairs in this, and for this you want to calculate mod of yi minus yj for all the pairs in this. So can you think of an optimal way? One way is to consider all the pair, but it will be back to that normal. So what can be an optimal way of doing this? Tell me. So let's say these are my points. Now if let's say I sort these points in ascending order, so you will get minus 1, 1, 2 and 3, right? Now let's say this is your point 0, this is your point 1, this is your point 2 and this is your point 3. Okay, if you sort these x coordinates in ascending order, then everything to the left of P3 will be smaller than the x coordinate of P3, isn't it? Yes, no? Yeah. Did you get it? So others read through the 2 lines that your friends have written. So can you relate to what they have written? Why sorting is necessary, I'll come to that, but is it clear? Did you get this point, what I have done over here? How is that going to make my life easy? I just gave a very simple example. I am simply saying that, hey, I am working with x coordinates and y coordinates separately. Now while working with x coordinates, I am saying, if let's say I sorted it in ascending order. Sorting in ascending order does what for me? That if let's say I am considering ith point, for this ith point I can consider everything from 0 to I minus 1 as reference points, right? So like for P3 I considered P3 P2, P3 P1, P3 P0. If you were at P2, then for P2 you were considering reference point as P0 and P1. And now because it is sorted, so the modulus of these differences will all open with plus sign. And if all of them are going to open with plus sign, then this thing, which is the first argument, is nothing but the x coordinate of this point. Okay, so it will be number of elements in the left multiplied by the x coordinate minus the sum of the x coordinates of previous elements. That would correspond to the sum of x coordinate distances, where this point is your reference point. Okay, so what can you do? Tell me, what can you do? So the main point over here is that you consider the x coordinate points. Guys, you understand this? No, I'm not sure like why is there bit silence over here, because let's say P0, P1, P2, P3. Okay, their x axis you are considering, but you have sorted them. And why you have sorted them? You have sorted them because the distance computation becomes easy for you, right? Now I am saying to consider all the NC2 points, consider them in this way. No, you consider the distance between P1, P0 distance between this and this, distance between this and this. That is what I am doing. So when I am here, if I know the sum from here to here, if that sum is s, then the little thing that I was doing here will be this sum being subtracted from the x coordinate of this multiplied by number of points, or the index of this. Index of this will correspond to the number of points, right? So you sort the array, and then what you do, you keep on taking the prefix sums. You simply keep on taking the prefix sums, and when you are keeping on taking the prefix sums, when you are over here, the contribution of this will be x coordinate of this multiplied by number of elements in the left, okay, minus whatever this sum was. Can you implement this? What will be the time complexity of this approach? N log n. Why n log n? Because you are sorting the x coordinates and you are sorting the y coordinates. That is the main time. And every other logic where you are computing the prefix sum from beginning, that can be taken care of very easily, I guess. So what was the most important thing over here? That whenever you have got these modulus signs with you, then try to deal with them separately. First deal with this and then deal with this. That way you will be able to, make the right set of choices for you. Okay, because modulus sometimes open with plus sign, sometimes it opens with minus sign. So if I sort, then I know that, hey, for this everything in the left is smaller, so it will always open with plus sign. So I am out of the danger zone of modulus. So that way you can solve it. So I think your code will look like, first you sort the x coordinates, then you sort the y coordinates, right? Then you initialize a variable distance of x coordinates, which is initially 0, okay? And then what you do is you initialize your prefix sum in x to 0, okay? Yeah. And then what you do, then you are trying to compute all the prefix sums in you are trying to compute all the distances of x coordinates. So for that, let's say you are iterating on your x array. This is your x array. You are iterating from 0 to n minus 1. Okay. So currently you are trying to consider the contribution of this ith element, a of I. So how many elements will be there in the left of a of I? I elements, right? There will be I elements. So and what is their sum? Their sum would have got stored in this thing, okay? So this thing I wish to subtract from what? Subtract from ai taken I number of times. So this will be the contribution of ith point, and this will increment my distance in x-axis. The same thing that you have done for x, you can do also for y, and eventually what you can return is dx plus dy, right? It's simple enough, correct?